Hello, everybody, and thank you for joining us today for another NeuroTools webinar. I hope the weather is as good where you are as it is where we are. Today, I have the pleasure of welcoming Dr. Hauke Bartsch as he speaks about the Red Queen's race, how transparency, interactivity, and gamification can be used to improve data quality. Dr. Bartsch holds a Ph.D. in Computational Neuroscience from the Technical University in Berlin. He has been responsible for software developments in the areas of diffusion tensor imaging, brain perfusion, whole slice image processing and reconstruction, brain mapping and atlas generation, deformable shape models, shape analysis, and general numerical simulations. Currently working as a programmer analyst in the Department of Radiology at the University of California, San Diego, Dr. Bartsch plays a key role in the development of the data exploration and hypothesis testing, otherwise known as data portal, used, for example, in the Pediatric Imaging Neurocognition and Genetics, PLING study, the Alzheimer's Disease Research Center, ADRC project, and in the Pediatric Longitudinal Imagine Neurocognition and Genetics, PLING, PLING study. Recently, the system was also adapted for the Human Connectome Project, HCP. Just a little bit of housekeeping. We do ask that you mute yourself during the webinar. If you do have a question, please feel free to type it into the group chat or voice it at the end of the webinar. If you feel it is pertinent to the current slide, I can absolutely voice it in the middle of the webinar as well. Without further ado, I'd like to hand the microphone over to Dr. Bartsch, and we will get this rolling. Thank you so much for joining us today, sir.
Thank you for the kind introduction. And as you heard, I'm originally German from Berlin, so excuse the accent. And thanks also for your trying to be kind to me introducing. It was a mouthful. So today, I am going to talk about a new project that we have started with our group here. There are many people involved, and I would like to show a little bit the tools that we have developed with a focus on image data analysis and collection, and also with focus on study design. So the tools that I'm going to present, I will try in the spirit of these NIS talks to show some actual live demos, are specific to one part, and there are many more parts. So excuse me if I'm not very specific about some things that might be close to your heart. Feel free to send us questions in the chat, and I think I will be able to answer them in the middle or at the very end of the talk. Thank you. So you might hear my mouse move every once in a while. Sorry for the noise. So the study we're working on right now is the ABCD study, and that stands for Adolescent Brain and Cognitive Development Study. And it's about the influence of childhood experiences on the brain and the behavior. So we are interested in genetics, we are interested in behavioral measures, and we also use imaging for to capture information. So the big questions we are trying to ask here is, how does, for example, screen time affect brain development? And what about traumatic brain injuries? Sports injuries, can they cause brain damage? How does sleep affect academic achievements? We all know there are big discussions going on about when you should get up in the morning as an adolescent, and if it wouldn't be better to shift school times a little bit around. So something like those questions is on the big agenda of the ABCD study. What are the long-term effects of ADHD medications? Is coffee good for you or bad? Alcohol, tobacco, and sports activities. So we have a lot of these questionnaires in them. So for each one of these questions, we we have to look at a collection of different measures that we get. And these collections, they're mostly imaging for what we are interested in, because that's a kind of one way to measure these patterns of activation or changes due to behavior. So that's at least one of the hopes that we have. So if the ABCD study is now around for like 2 years. If we compare it with what we did before, I just wanted to show you a little bit where we have been with another study, which is, as was mentioned, the Pediatric Imaging, Neurocognition, and Genetics study, and what the scale of the ABCD study is. And this is, in a way, a motivation to give you a motivation for this particular talk. So the PLING study, we did collect data over 3 years, and it was about 1,400 participants. And the data were collected at 9 different sites. Now with the ABCD study, we have 21 sites, and the data that we collect is actually 11,500 participants, and they come back every 2 years. So we have a study that we did in the past, and we know, we learned a lot. There was a single time point study, and now we have a study that has 19 different time points over 10 years. That's like one time point every 6 months. So people at the different data collection sites try to get the participants back in, and then we do imaging studies again, and we do questionnaires again at regular intervals. So for the PLING study, we also were lucky, and it's basically a short enough time period so that the data sharing could be done after the study. There was a separate effort. Now with the ABCD study and the amount of effort spent on it, everybody is very interested in getting instantaneous access to the data. So we have, for ABCD, we had to set up several data sharing mechanisms. And one of them for the image data, for example, is instantaneous, or instantaneous at a given level of instantaneousness. In this case, we are supposed to share fast-track data the moment it arrives at our institution. So, which is basically a 2-week time window, and then the data goes out in the world, and people are able to analyze it. We support 3 different scanner platforms, and for ABCD, we have developed a harmonized scanning protocol so that the scanners all support the same image quality. And those scanner manufacturers, we use MRI scanners. They're named General Electric, Philips, and the Siemens platform. So, and those are the most widely used ones. So we are attempting with this approach to make it available, make the scanning protocol available to other sites as well that would like to collect data with similar quality. So the data that we collect is basically anatomical, T1, T2. We have diffusion weighted images. We have resting state data, and we have 3 functional scans in ABCD. If you compare it with the original, there is about a factor of 20. So PLING study is a little bit older, maybe like 5-6 years old. ABCD, as you know, everything gets more complex, higher resolution, better image quality means more images. So if we compare, for example, what we did in PLING, we end up with about maybe 10,000 images. And now for ABCD, we end up in the order of 250,000 images per single participant. And those image data, they are generated at the 21 sites, and they have to go to us. And that's one of the things I would like to show you a little bit about how this is done at our institution and what tools we have developed to make that possible. So for ABCD, we are also responsible for all the non-imaging data, which, as you know, is as big as imaging data. If you compare just the manpower, or in this case, measured as full-time equivalent for the PLING study and for the ABCD study, you can see that we have about 3 times as many people in the ABCD study, and I will basically try to show you where the effort goes. So once you collect the data and you do data analysis for image data on the PLING study, and then how did we change it to end up with ABCD study data. Okay, so it basically is like a factor of 10, maybe a factor of 30. It depends how you count. So we have a bigger study, and we have about 30 times more visits for participants to work with, but we basically only have, you know, a nominal increase in the amount of people that are working on it, like 3 times more FTE for 30 times more work. So if we look at what we have to solve is basically this title-giving conundrum here. I'm just reading Lewis Carroll's Red Queen. Now here you see it takes all the running you can do to keep in the same place. And if you want to get somewhere else, you must run at least twice as fast as that. And basically what we have to do is we have to run more than twice as fast to be able to keep up with demands of, you know, new studies that come online. And they will not have less image data and less participants and less image visits, but they will have more. So how do we approach this? So there are some resources that we have that do scale with the amount of data that we have. So as you know, data collection is not easy. So there is a limit on how many people you can scan per day on an MRI scanner. And our data collection sites, the number of data collection sites basically increased. And each of the data collection sites, they have their own research assistants, data managers, IT and network experts, principal investigators, postdocs that are interested in collecting the data and interested in analyzing them. So we basically try to integrate the data collection sites into all aspects of the data analysis. So the goal is to use them as assets. It should be really easy for them to do the work, and then some. And that additional part we have implemented in ABCD as them being able to take part in the data curation. And I will try to explain a little bit what we mean by data curation and how they're able to do the brunt work, the brunt amount of work. The most of the actual data curation is handled by all of these different people. We also, if you compare, you know, if you're on the first slide, I showed PLING. We do have 4 software developers, and those ones also scale with the data. So if you can develop tools, then it becomes very easy to apply the same tool to just more data. So that kind of scaling is a good one as well. So we try to make our developers, you know, give them a framework to make it really easy to create the needed tools in the least amount of work. I will like start with point 1, so the data collection sites. If we look at the 21 sites that collect the data, then for ABCD they are running on average 250 participants per year. And you can see there that we have sites that are doing substantially more. So we have like one site that is doing about 500 scan sessions per year. And you can imagine that's more than 1 per day. And that is not something that you can do on the weekend and in a normal research setting. But this is something that requires dedicated devices at those sites. So in order to allow them to do this, we basically try to provide a one-click for everything. So there is like a one-click for the scanner to send the data off the scanner, and I will show you in a minute why. And then a one click to transfer the data after it has been reviewed at the site to ABCD Central, where all the data is analyzed finally and quality checked the second time. So the we are using this harmonized vendor protocol, so it's actually supported by the vendors. So we don't have to do anything specific on the machines. We basically just install the protocol, and then people can easily use it to collect about 2.5 hours worth of image data for our participants. And when we collect this amount of data in order to make, get the best image quality, we're using a harmonized protocol based on the Human Connectome protocol. We do generate substantial amount of data on these scanners per scan. And actually, with the amount of data that we generate with this protocol, there is only space on the MRI console for about 3 or 4 of these scans before their hard drive fills up. So you can see there, the MRI scanner console has like 1 terabyte hard drives. So that was one of our first hurdles when we realized that data has to move off the MRI scanner console as fast as possible, because otherwise we will be able to collect data, but we might never receive the data if it is overwritten by other operations that are happening on those scanners or by other ABCD scans. So we also wanted to allow sites to correct data entry errors. So when they create a scan session, they're asked to enter a patient ID and a patient name. And for the ABCD project, this is an anonymized ID. But the anonymized ID, you can imagine, is not very easy to memorize, and people tend to make errors if they have a lot of other things going on at the same time. For example, making the participant in the scanner feeling that everything is okay. So we had therefore the idea to place a separate system at each of the 21 sites. Those ones we use an NFS project, and the systems are called flash-based input-output network appliances. So we all call them Fionas, and those ones are workstations that we have equipped and shipped to the data collection sites. They're installed inside the scanner's network. So this requires support from the centers, from the imaging centers at these different sites, and they have to allow us to place this workstation inside their network. The upside for this is that the Fiona workstation has substantial amounts of storage. So there's 20 terabytes fast storage on there. So it is very easy for the scanner to forward the important data to these systems. Because they're local, these connections tend to work and be very high performant. The system, because it is a real workstation, is not a smaller device that just uses like an edge type of design to just tunnel data through. They're actually real workstations with CPU, and therefore they can be used by the sites to do protocol compliance checks. So we do these checks on the data that we receive from the scanners in order to detect any change that is done on the scan protocol. And we alert them basically to these changes in web interface I will demonstrate in a minute, and therefore hopefully sites are able to correct. So the Fiona integrates with the MRI scanner network and talks DICOM, so it receives direct data from the scanner, and then it pre-packages those DICOM files into image series and forwards them over a secure channel to the central ABCD data storage facility. And that communication is done using SSH, secured SFTP type of communication channels. So which result in a small number of very large files that have to be transferred. All of this is automated, and the Fiona system also supports multiple scanners per site, and you can have more than one Fiona. And we also have sites that use the Fionas for other projects. Okay, so this is a view of what the system looks like. I will try to go out of my presentation, and then.
Hey, Dr. Bartsch, just want to hop in there. We have a point made on your last slide. Dr. Bandrowski brought up the idea that the participants are currently 10 to 11 years old, so making them feel comfortable is probably quite critical. Would you agree with that?
Yes. I have to say that I'm pretty ignorant on this part, because I'm basically on the receiving end once the data comes. But there are about 500 people at all of these different sites and inside ABCD, with the primary purpose of making sure that the data has a good quality when it comes in. So our participants are 8 to 9 years old currently, and we will follow them for the next 10 years. And I fully agree that there is so much work that has to be done. Sometimes we have looked at the data, and there is a clear correlation of the capabilities, the dedication that the site puts forward, and the amount of data we get, and the quality as well. Quality, for example, measured as minutes that they stay and just stare at a crosshair, for a resting state scan, or for a functional scan. Yes, I appreciate the sentiment.
Absolutely, thank you.
So I'm showing you the web interface of one of our Fiona systems that we have in the field right now, and it basically is a single page. It looks like this. There is a list of scans, and they're all anonymized. And then there is some information about the status of the machine, so how much space is on there, how frequently is it used. There is on the top right 2 checkboxes. You can enable or disable the machine on the network. So if you disable it, then scanners cannot forward data anymore to the system. We use this to limit the access to the Fiona, to ABCD projects, and the work that goes on. And you can also see a calendar, and the calendar is listing the image sessions that have been forwarded into the Fiona system. And from here, you're able to select one. I'm using my mouse right now to click on the ABCD phantom scans, and we require them to do phantom scans at regular intervals. If I select the latest phantom scan, we get a study transfer dialog. So that was kind of 2 mouse clicks. And in that study transfer dialog, you can see the information that has been entered at the scanner, and which is the top part. And there is a second part where we asked the sites to identify imaging sessions. So imaging sessions in this case is an important concept for us, because when the data is entered on the scanner, people can make errors. In this case, there is 3 different fields. There's a drop-down for the participant ID, and you can open it, and then you can start typing to pick up a specific ID for a participant. There is a session, so the imaging session that you want to run. And then there is a third field where you can identify what type of scan you have done. And we have several ones. In this case, it's a QA, so it's a phantom scan. So people would select the last field. The nice thing about this interface is the system is located at the site, so it's inside the site network, but it does correctly link to our central data repository. So when we enroll a participant, we have to go through consent and assent for the parent and the participant, and then they become an official GUID, generalized user identification number. And those identification numbers, we show them at the sites, and those are only the IDs that are relevant for that site. So you can see here, if you scroll down, there are all of these IDs. People are expected to select one, so they cannot type into this field. And then they provide the session information and the image session. And this is the essential part that links the data done on the scanner with the central repository. We require them to do this one step. You can see here in the bottom half of the screen that this is a compliant QA scan, and you can see there's individual send buttons. If I use the drop down here and just scroll through, there are some image series that are flagged in red, some that are flagged in green. Green is good, red is bad. But in this case, there are probably additional series that have been acquired for the same participant, but are not part of the normal protocol. So they review this section, and if they see all the scans are green, that are essential for ABCD, then there is a single button click here at the end, which is called Send All Series. And that's sufficient for the system to send out the data to the central repository. So the interface for the Fiona system that sits in between the scanner and our data collection site is fully driven by this one web interface. And people have been using it successfully at these 21 sites for many months now. And we reliably receive data from them. The system gets information from our central repository, and it also announces data back to the central repository. So all good things that we were able to develop because we have this physical system at the sites. So we don't require sites to zip up files or to handle data uploads in some other way. It is done through this web interface. Okay. And we'll just continue with the next slides in this case. The second resource that I mentioned, so one is making it very easy for the sites. The second resource we have to handle the larger amount every new study is to actually use our developers wise. So I can just show you a little bit how our accelerated tool development works. So we have Monday meetings and Friday meetings, and you can see here some examples for questions that we have at the Data Analysis and Informatics Center. So we have a question coming in, and then how can we measure school recruitment? And then the next Friday, there is questions about usable minutes of resting state data. And we have weekly meetings. So the next Monday is how can we measure retention? And the next Friday meeting is how can we measure radiology review delays? So for that, basically, you see Monday, Friday. That leaves a couple of days in the middle of the week to finalize each of these requirements, because otherwise they will just pile up and we won't be able to answer any one of these questions. So what we have done in order to make this as easy as possible on us and to enable other researchers at the different sites to participate, We are focusing on single purpose tools, and most of them are just graphs. So those are single page applications, and I encourage everyone to read up on Edward Tufte, because he has some nice ideas about using whitespace. There is an implicit assumption in our setup, that we can only work if that's actually true, that people are using quite powerful machines at the different sites. So I'm talking about laptops, I'm talking about workstations at their desk. To enable them to use our applications, they have to have sufficient amount of memory, and basically be able to render a web page correctly. So we work with minimalistic server backend for any one of those applications that we develop, and I will show you a little bit what the functionality is of the web browser, in this case as the client, and of the server, which is on our end a centralized system. So we prefer this cookie cutter approach to set up a new application. So usually if we have the Monday meeting, in order to set up a graph that would show school recruitment, it is usually less than 10 minutes before we have to think about which data do we have to process in what way, and what does the final graph look like. So we have focused on a specific number of technologies. You can see them here at the end of the slide. So of course it's good to do things that you know about, but they also have to be in this technological Goldilocks zone. So they shouldn't be too basic and also not too complex. So we tend at our sites to avoid technologies like Java, Tomcat, SOAP, and XML. This is mainly, of course, driven by the expertise that exists on our side, but it also plays into this too complex kind of category. So we do interface with a lot of REST API services, which is a newer way to interconnect different services. But even those are for most of our cases too complex. So we instead tend to use JSON APIs. We work heavily with JavaScript and libraries like D3.js, or Shiny. We use CSS and SVG for graphic rendering, and on the server we are focusing on PHP, which is very, very easy to use and reuse. And for more complex applications, we are using Node.js. Okay, so the framework for applications is really a very simple one. We have the application logic on the client. So when you go to our applications, you end up on a web page, and everything happens on your laptop when you look at the web page. So the web page is pulling data from the server using AJAX calls, and the data arrives from the server in JSON format, which the web page natively understands. And then the JavaScript on the client is processing the data, filtering the data, and preparing them for display. And then there is a separate component on the web page that then renders the resulting images. We tend to use nearly exclusively D3.js because it has two obvious benefits. One is that there is a lot of examples for visualizations that already exist, which you can readily integrate into your programs. The second one is that it is low level enough to come up with completely new visualizations and displays. We have found that this is really important because people will come to us and say, can you, add percentage values on top of each of the bars. And if you are using a setup that is too rigid, you won't be able to solve this easily. If you use something, a framework like D3JS and SVG, it's really easy to add those features. The server, so this is the client, the server only supports authentication and authorization. And of course it does logging. So we have, people have to log in, and they have to have a user account on the system that has some specific roles. So we use access control lists that support permissions grouped into roles, and then we can assign those permissions to users. So the server-side code for a simple application is really just check if the user is logged in and has authorization for the current page. Then we check the get and post arguments to identify what is the requested functionality from the page. So basically which button did the user click. And then periodically the server will also update its read and data cache from the central database. And this is probably the most important piece, that our application framework always has direct access to the central database. There is no separate cache. There is no upload of data every once in a month. This is, we tend to use a direct live connection to our database system. Okay, so I can show you another demo for this. If I switch to our report framework, so our web page for reporting basically looks like this. So people, I'm logged in at this point. At least I hope I'm still logged in. And then every one of our applications is behind one of these icons. And whenever we have to solve a specific new problem, we will add another icon and give it a flashy picture so that it becomes easy to recognize what particular function this is. If I scroll down here, I want to show you two things. One is the study observation tool. The other one is the data dictionary tool. I've opened them already. So the study observation tool is a very simple approach of measuring events in ABCD. And in this case, it is just a calendar, and it's a calendar for each of our functions that we measure. You can see here auto scoring, and each of the squares represents a specific day, in a specific month, in a specific year. And if I scroll down, you can see that some events happen very consistently, and some events happen sporadically. And we basically use this page, and we can look at it every day, every single day, to identify if for the current day everything happened. You can see here marked enrolled. There is something on 04, 05, and there is nothing up here. So of course it depends when this particular function is executing. So it might be at night, it might be on the following day. We tend to look at this at weekly intervals. So is anything on our system change? Is there a change in the way that data is collected? If I scroll a little bit further, here is our PII database, and how frequently are people are sites creating new contacts. And you can see that there is a clear pattern of the weekend, which is the first row, and the last row, with and then there's a different pattern in the middle of the week. You see the same here for logins, activity that are in our REDCap centralized database, radiology review. So the page function is a single function, which is to show single events. And we always use the same methodology to show them, which is in this case a calendar view, and we allow people to compare their current progress with the month before, and several months before up to a year in this case. So this is one of our very simple applications, and it was basically started because we wanted to measure the repeating script executions that happen on our end. Right now, we are measuring a lot more, and with the study observation framework, it's really easy to add another one of these scores. So you basically only have to send a single package to this website, and that will be sufficient to create a new category and to start measuring the TikToks that we get for this particular service. The second application I wanted to show you in this respect is in this part is the data dictionary commentary. So we have with 2 days collecting information from participants and the parents of these participants. We have a large number of measures in our database that are imaging or non-imaging related. We have a current count of about 40,000 of these measures. So it was essential for us to allow the different sites to document how they use a specific measure, if they have questions about that measure, and what the structure of the measures is in terms of work groups, in terms of data collection instruments, and then inside the data collection instruments in the order in which these questions have been asked. So the data dictionary commentary application, you can select on the menu your domain, and we have culture and environment currently open. There is biospecimen domain, health and mental health, neurocognition, substance use, and imaging. So each of those domains has a large number of measures, and the page allows you to select which domain you're working on. And it shows you on the left the instrument structure, so you can select to go to a specific part. In this case, it's the parent notes for the 1-year follow-up, and then you can scroll through and you can leave a message here on the right. So these messages, they're usually attached to our data items. They don't necessarily end up in our data dictionary. They're kind of prepared notes to prepare for changes in our data dictionaries. And the application that we have here, the single page application, this is its own, this is the only use case for this particular application. It's a single page, and you select your work group, and then you can search for a given measure, and you will see what the coding is that is used to ask this question, to store the value, and then you can leave a message, and this way communicates to other workgroup members and also back to the central repository. Okay, if I go back to the next slide. So the one additional task that we have is the study observation. And so we have to implement continuous data tracking and curation. So we are, if you know Murphy's Law, everything that can go wrong will go wrong if you let it. So we try to measure everything all the time. We try to show everything to everyone all the time. And we also try to have the data collection sites have control over their data in our central database. So reporting is the key for all of those. And just to give you a list of the people that use our reports, so we have the data collection site, but we also have the coordinating center, the funding agency, we have a lot of scientific work groups, we have the principal investigators, and we also have external advisory boards. So they all have access to our progress report framework. And of course, different progress reports for different people. So the user account on this system I'm showing here, this is not all the active users, but it's basically the user accounts for about 2 years. It's 490. The progress reports are updated every 2 hours. And that's essential because sites use them while visits are still ongoing. So when they have the parent and the participant, the child, in the study, they will have a chance after a couple of hours to review the progress and identify any kind of missing values. We show also in the progress report site performance. So we measure specific metrics and we show them for each of the sites. We show the difference between target values and the current values. This includes, for example, demographic targets or targets for income groups. Most of this is interesting for recruitment. We have direct access for anonymized participant identifiers, and then I want to show you a little bit what it looks like. So we, on the ABCD report, there is one application which is called the progress report. And if I have it open in a tab, if I go to the progress report, then it's a collection of different graphs, each one updated every 2 hours based on our latest data that we have, and each one particular to a specific question. In this case, the first one is the enrollment status, and I can, we have 3 different graphs. We have enrollment projection, which is also on here. And the next one is completeness, then completeness for the first year and completeness for the baseline. You can see that these graphs follow basically a time axis in a normal project. So we always are worried first about do we get enough participants? And then secondly, we are worried about do we get all the data for all of the participants? And then if you go down, do we get current data, or is there any problem with those? There is a theme you can see here on these graphs. They usually have a title, like sex at birth, and then an explanation for which variables in our central database feed into this. So it basically explains the provenance of the graph. And then there is a row of these orange buttons, which show key process identifiers. So in this case, how many others do we have in the study? There's a small graph at the bottom, which also shows in relation to the start of the study, what is the time course. So if you can see here for male and female, it's basically both going steadily up. For other, we tend to have this as a late, it's close to the current time point on the far right here, and this is like in the past. So people sometimes don't provide the correct value, and then they correct them, and then 2 hours later the number goes from 12 to 11 to 10, and that's how they can improve the data. So we show this to the site, and the site would basically just read the 12 here, and then select that box, and then it sees the list of participant identifiers. So it has direct access to the data that is used, that was classified under this heading. You can see then there's a graph. In this case, you can click on it to get different flavors of the same graph if you prefer one over the other. If you scroll a little bit further down, the next section is the screener risk. So we ask them some initial questions that are related to a generalized risk. Is not a very good measure, but we have been using it to guide some of our tracking inside the ABCD study. And you have in this one low risk and high risk. So one of the features that are really nice is we can use these orange buttons in conjunction. So you can take, for example, the orange box for the screener high risk, and you can drop it on the other that we just looked at sex category. And if you do this, then the web page, because it is, it has all the source code is on that web page, has access to these two lists, to the list of participants that are classified as being high risk, and I'm doing like high risk in air quotes here, so you can't see me, but a specific measure of risk in this case. And you will see how many participants are in either the one category or the other, and how many participants are in both of them. So this is a nice feature for sites to drill down into specifics. Usually what people have to do is they have to open two of the web pages and have them side by side, and then it becomes really easy to use any of the measure on the left, and you drag and drop it to a measure on the right. So you can see here examples for ethnicity. There's an inner ring for the target and an outer ring for what they should be. So if we go back to our presentation and just finish it, these graphs are used to inform sites about errors in the data. They have access to the data repository. They can fix errors while the participant is still in the room, which is nice. We try to integrate them with data curation. So the data curation part is improving the study data at the primary storage location by changing the process to collect the data and then transform the existing data to agree with the new process. So we have been developing tools to enable this at the sites. So here is one example for scoring, and this is something that, where non-developers can create scoring algorithms. You can see a couple are listed on here. We are heavily using this framework. Here's an example of what the scoring looks like. It's a data flow graph. So you start with measures, and then you feed them into boxes, and then they're put back into the central database. So as a summary, it's important for us to try to get good data, and I have listed here a long list of all the keystone things that we try to adhere to, and what that we think in our study have been of interest. I would like to leave you on this page and maybe try to get a couple of questions.
Thank you, Dr. Bartsch. Yeah, we'll open the questions now. Open the floor for a few questions. We did have, we got Anita live. I'm gonna mute myself.
So hi, yeah, this was great. Thank you so much for doing this, and I think this will be great. It's really nice to see what these tools actually do in action. So that's fantastic. But I was actually wondering about some things about the participants. So what is kind of the expected rate of dropout of these kids? Do you guys have an idea of what that will look like? I mean, this is a huge study with so many participants. I'm sure you have thought about this.
Yes, yeah. We have a target number of participants, and that is, of course, driven by the core hypotheses that we want to be able to answer at the end of the study, which is in 10 years. So we want to follow them when they're naive with not that many head injuries and medication and drug use, etc. And then we want to have a sufficient number of those participants left in the study after 10 years. So the target that we have is 10,000 participants at the 10-year mark. And we are enrolling 11,500. So you can see that that's a pretty narrow gap. So we now that we are good with recruitment, and we're good with collecting the data and with data sharing, we are focusing now on retention. So if I show you this on the ABCD report page, I explained, the further down you go, the more the more current the application. There is an application for retention, and it's specifically on the retention. And you can actually see there how many people we haven't, we are losing right now. It's a snapshot. It changes every day. 32. And if I scroll up again, here's the number for our current enrollment, which is 9,131. So we have a couple of months more to finish recruitment to get the 11,500.
Oh, very good. So the other thing I was, I might want to ask, does anybody else have questions? Because
I do have a quick question, which is about the usability of the tile page that you just had up. So over time, as new tools are developed, I imagine that page could get quite long. And have you thought about how to help people find the tools that they need or use regularly, as well as discover tools that might be relevant for their work, for their particular question?
Yeah, that's a very good question. And for us, as you can see on this page, it is kind of a bridge we have to cross soon. But you have to realize that sites are doing about 3-4 scans a week. So the people working on the project, they are really, really familiar with this interface.
Okay,
it is an issue for people that are not that frequently going to the page, but the most of our users have this open every single day of their work. So we try to make it easy. We try to make very flashy pictures on this page so that it becomes easy to recognize just by scrolling down and clicking on it. We tend not to show any kind of hierarchies, so where you have to click first and then you might get basically blind to changes. So everything is very flat on this page. But for retention, for example, I showed the progress report, and just the size of the scroll bar here on the right tells you that even this particular application has a lot of issues with how much data is displayed. So luckily, people are very familiar with them and they appreciate a single page. They look sufficiently dissimilar with each other to allow them to pick the graph they're interested in at any point in time. But it will be a problem in the future, I'm sure.
Mm-hmm, mm-hmm.
And we do have a question in the chat as well. I just want to get it in before noon. Sorry, I didn't mean to interrupt you, Tom, if you had a follow-up.
No, I got to hop off as well. So thank you very much. Great talk.
Yeah, you're welcome. Thank you for joining.
Our question from the chat is from Leon Rosenblit. I hope I said that correctly. And it has to do with the tools. Are they open source? And if so, is there a URL we could point to for the repository?
Oh, and maybe which RRID they're associated with?
Absolutely.
Yes. Yeah. Of course, we have RRIDs for everything, and I'm very happy to provide them. We should probably add them to the page so they're available. With respect to the data, of course, we have a GitHub repository for the ABCD study, and you will find all the data sets in that one. So have a look at github.com ABCD-study.
Excellent, and I'll type that into the group chat right now as well. Well, I think on that, there it is, github.com/abcstudy. Actually, you can see it on the presentation right now. I think that is all of the questions from our group chat. I'm scrolling through it. Yeah, I think we got all of them. Dr. Bartsch, is there anything else you'd like to add at this juncture?
I would like to say thank you for the opportunity. is happy to show off the stuff of a lot of hard work.
Absolutely. We're very pleased that you were able to join us today. Well, on that note, I think I am going to end the webinar. This will be on YouTube momentarily. I'll just make a few edits to the beginning so it starts when we want it to start. And I just want to give a quick thank you, first of all, again, to Dr. Bartsch for joining us today. And also a very quick plug for our next webinar that we have scheduled, which is actually in June. So I think I'll hold off on that plug for now because we will have a few more webinars likely scheduled in the upcoming weeks. So please check in with our new info upcoming webinar website. I'm going to type that into the chat right now. You can also find recordings of all of our webinars on this website, which are on YouTube. Okay, that's the plug. Thank you again, Dr. Bartsch, for joining us, and thank you to everyone who joined our live webinar.